Okay, so in this video we are going to do a complete deep dive into SGID and SUID. If you have never heard of these before, don't worry. We'll start from very foundational understanding how Linux control what a program is actually allowed to do and why these permission exist in the first place. And if you have already some idea about this SGID and SUID, we'll also be getting into the exploitations side, where we will look at how attacker actually identify and abuse these permission to escalate from low privilege to root access. So by the end of this video, you will have a solid understanding of both the concept and the attack. So without any further delay, let's get started. Okay, so we will first of all discuss the what is SUID, and then we will talk about the SGID, and in the coming video we will talk about the capabilities. Okay, so to really understand SUID, first we need to understand how Linux normally decide what a program is allowed to do. Like when we run a program, how does it decide what it is allowed to do and what it is not? Like sometimes we wants to create a file or edits a file, but we don't have the permission. So how does that work? Today we will first of all discuss this. When we run a program, let's say the ls program. Okay, so Linux, what actually Linux does, it actually look at who is the person who is running this ls program and decide based on our identity. So our identity is Karen. Let me actually show you. If I type the id command, you see right here we are Karen, and we are actually a normal user, not a root user. So when we run the ls command, it will run with our permission, and right here you can see it can only read file that Karen can read and modify that only Karen can, and it won't be able to touch or do anything with the file that requires a root. Or let's say there is a file, it cannot actually touch anything that that requires root, right? So because this guy have low permissions, basically the ls program in this example inherits our permission, and based on that permission it do the stuff what we are allowed to do and what we are not allowed to do. And this is called actually the real UID or the user ID, the actual user who launched the process. Like right here you see this is the UID. Our UID is 1003. If you know that I have already discussed that the root ID is 0, and the normal user, the user we create on Linux, the ID start from 1000 and so on. So right here this is the 1003, so it means two other user exist on this machine as well. Now if I scroll, and you can see right here there is a problem. Like for example, I want to change the password for this specific user. This is specifically one example. This is one of the most known examples. So let's say I want to change the password for this user. What actually happens is that this user, as you might know, this is a low privilege this is a low privilege user. What I mean by that, this guy have actually low permissions. So the file where the passwords are stored, right here you can see this is the shadow file where the passwords are stored. And the main problem there is, let's say this user wants to change password, but this file is actually owned by a root user. And as I said over here, only root can write to or modify this file. And if only root is allowed to modify this file, and this is the exact file where the passwords are stored, how is this user gonna change his password if he cannot write to this or modify this file? So the main answer is the SUID, which means set user ID, and it is a special permission, a special flag, a special kind of feature we can give to executable file or any file. So when we set the or enable the SUID on a file or executable file or any file, does not matter, and that specific file is owned by a root, so something special happens actually. So and when we try to run the or modify or try to write to that file that is owned by the root and the SUID bit is enabled on that file, what actually happen is instead of running with the permission of the person who executed it, like in this case the ls program who takes the user ID, it actually runs with the permission of the file's owner. So what I mean by that is, so when Karen runs the pass command or pass program, we use this to change the password, and this actually write to this shadow file. So assume we have set the SUID on this file on this executable program. So when we run this passw command, passw tool, even though it is a root, the owner of this file is a root. So when we run this program with a normal user, with the user Karen, what actually it does is the passw program run with the root permission, because the SUID is enabled on that executable file, and because root can write or modify this file, so when we give our new password, this passw tool, this passw program actually modify this file, and this is how we as a normal user change our password. So let me show you who is the owner of this file. Let me copy this and go over here and type the ls-l and then this specific file. Yep, so right here you see the owner of this file is root, okay, and the group of this file is also root. So as I said, when we run this program, what actually happen is that it run with the user, instead of running with the user permission, it run with the root permission. And this s right here you see, this means the SUID is enabled on this executable file, and when we run this, it actually write or modify to that shadow file, and that's how we actually change our password. Now Linux has two IDs for every running process. One is the real ID. I hope you can see that who real ID mean who actually launched this process, like here in the example I give you for this ls program. And then we have another ID which is called effective view ID. So this is relevant to this passw program. Like when we run this program or any program that has the SUID, it effective UID user ID means that whose permission are actually being used. Like in this case, instead of our permission, the current permission being used, the root permission are being used in this case. We can actually do the practical of like doing, we will run the passw tool or program, and what we will do is we will then see who is this running with, like is it running with the current permission, the normal user permission, or is it running with the root permission. So what we're gonna do is, okay, so right here you can see I have started this program and I have just left it like this, and then what I did over here is that I run this command to see with what user or with what permission this program is running. So right here you can see this is actually running with the root user, even though I am a test user, this is a normal user, and it is running with the root user. And then I run this command, you can see this is status, and it actually show the real ID which I talk about. This is the real UID, okay, this is the real, and these are the effective UID. This is the root user ID, and this is the root user group ID. So this is how it works, and you can see similar response over here as well. Okay, so what is the problem with all this that we have talked about? This is the exact mechanism attacker abuse. If a program has SUID and it has any vulnerability or feature that lets you run other command, okay, so we talked about in the previous video that you are actually exploiting the tools or program that we were able to run with the sudo permission, even though we were normal user. There were some program that has some kind of special feature that let us to run or execute command. So what we used to do is we used to first type the sudo and then the program we were able to run, and then I used to type the program name, like this is like for example sudo, and then let's say nmap, and then there were a special feature called interactive. So this was the special feature that was letting us to run the command. So once we run this, that will let me give the root shell. So this is what it is talking about. Those commands also run with root's effective ID. So if you are interested to watch the video about the sudo misconfiguration that I just talked about, just this is the video that I'm talking about, so make sure to give it a try and watch it. It's very good. Now let's get back to where we left. So I hope you understand the SUID, what actually this is and how it works and how it can be abused. Like right now we have not talked about how we can abuse it, but the mechanism, how it works and what it actually do. Hope you understand all of these things that I have explained. Now we will talk about the SGID, and after that we will talk about how we can actually exploit it. So now let's just talk about the SGID. So this SGID pet works exactly the same way but for groups instead of user. What I mean by that is in SUID what we used to do is we were setting the or enabling the SUID on a specific executable file, and now in this, instead of the file, we enable the same thing but on directory on a folder. So like right here you see, when a file has SGID set, it runs with the permission of the file's group owner. Okay, so let's say there is a group or there is a folder I created and its group is root, and I have enabled the SGID on that group on that folder, and let's say I create a file inside that directory. So and when I run that, what will happen is that instead of the file that I created running with its own permission, it will run with the folder group. And as I said, the folder group, let's assume, is the root user, so that file will actually run with the root user using the effective UID that I just talked about. And to find out which file has the SUID, which specific file has the SUID, and which folder has the SGID enabled or no, so we used to type, so we have the commands ls and with the hyphen l, so it gives us the detailed information like this. If I go over here and type the ls hyphen la, so right here whatever file we have in the root directory, it is giving me a detail that who can write to this file and what they can do exactly. So as you might already know, this specific block is for the user, and this block is for the group, and this block is for the other people. So when you want to check and when you want to see if the SUID is enabled on a specific file or no, you will just type the same command that I just typed over here, the ls-la, and you will need to look for this specific block. If you see the S character in the user block, it means the SUID is enabled on that specific file. And let's say if you want to check the SGID, what you will do is we'll then look for the S character in this group block. If you see the S, it means the SGID is enabled, and whatever file you create in that directory, it will execute with the group, it will execute with the folder permission. And right here it says for privilege escalation, SUID is more commonly abused because it elevates to root. SGID elevates to group, still useful, but if the group has access to sensitive files or program, meaning in simple time it means that we mostly care about the SUID more likely instead of the SGID. And if I scroll a bit down, and let me scroll a bit and see what we're gonna discuss next. Okay, so we're gonna use the find command, the find program. In the we will then search for the programs or the file that has the SUID or SGID enabled. Hope this all makes sense, and if you want to understand the SUID and SGID a bit more in detail, just come over here to this channel, and I have actually made separate videos on both of these. So this is the video on the SUID and this is about the SGID. I have discussed about, like, first of all I discussed the theory of these, like how these actually work, and then I did the practical, like how we gonna give the permission, the enable the SUID and SGID, and how we can remove those SGID and SUID. So if you are interested, just watch this video. It will make a bit more sense if you don't understand it right here. And now let me scroll a bit and see what we're gonna do next. Okay, so now we will try to find out the file that has the SUID enabled. So we're gonna use the find command in the root directory, and what it's gonna do is it will start the searching from the root, look everywhere, it will look everywhere. And what we are trying to look for using the find command is we are then specifying the hyphen type F, and this means only look at files, not directory, not any other thing, just for the files. And then we specify another flag, the permission flag, and then this specific thing. And what this is, what actually this overall means is that find file where the permission bits include this, and this thing right here mean these are the permission for read, write, execute permission. Okay, like this is the permission for the user group or block, and this is for the group, and this is for the other. It's actually in the octal notation. If you don't understand the octal notation, I have again specifically made video on this. This is the video, I think. So if you don't understand and wants to learn about the octal notation, just watch this video. This is also very good. Now coming back to this specifically mean is the octal notation, as I said, of the SUID bit. It will just kind of find out the files that has the SUID enabled. I'm not going to explain the octal notation over here because it's a bit more, it will make the video a bit more detailed. As I told you, these are the for the user block, the group block, and the other block, and this specific for is used for enabling the SUID on a file. So this will try to find out the file that has the SUID, and then we are not only seeing the file name, but we are actually seeing their detail, like a detailed overview of all of those files that has the SUID. And then this, you might already know, whatever error we get, we just forward it to this dev/null, and it just kind of remove that or deletes it auto. And as you might already know about this, whatever errors we get while running this command, it will send the error message to this directory, and it will throw them away, and it won't actually show to us in the terminal errors like permission denied or some other errors. So the reason for this is our output, the output we will get will be clean and it won't be a mess. So let me scroll a bit more, and once we run that command that I just talked about, we'll get something like this. Let me actually copy this specific command and run it myself on this machine. So as you see right here, we are getting a lot of file that has the SUID enabled. And let's come back to this, and so you see right here the same output we got like this, and both are kind of the same, but the cloud just added a few files just to give us idea. And so the output is kind of same, and what we're gonna do is, I don't know what these are, and Claude also just ignored it. So what I think is important is that these permission, the what we can do, what a user can do who own the file and the group and the other as well. So this is important. And the next thing is, these are actually permission that I just talked about. If you want to look if the SUID is enabled or not, you will just look for the S character, and then we have the one just mean number of hard links. I don't know what this means. And then we have the file owner, and then the file group. So this file owner is root, and its group is also root. If you remember in the starting of this video, I just showed you the owner and the group of this file, and we can do the same for these as well. And then we have some these random numbers. What this means is, these are the actual file size in bytes, and then these dates is about like when this file specifically is being modified. Like let's say if I want to use this command and change the password for a user, so the shadow file will be modified and the date will be also changed for that. And this is the exact path, the full path that does tell us where the program is. So if I go over here, these are the read, write, execute permission for the user group, and for the other this is the owner, and this is the group ID, group name, and then we have the file size, how much the file size is, and this is the date that is being modified last time, this file. Okay, and this is actually the full path of this program. Now we need to check what is normal. Like there will be some normal file that we actually needed the SUID enable on, like this specific one, the passw program. We need to filter out the malicious one that we can use for our own purpose, that we can use to get some kind of root access. So we gonna do this now. As you can see, these are expected on Linux to have the SUID enable, the passw program, the sudo, the su, and a bunch of more you can see. And to find the ones that we actually need is that one is the find vim, nano, less program, bash, python 3, and a bunch more. So if the find program has the SUID enabled, what we gonna do is it can give us an instant root shell. And same is the case for the vim. This is actually a text editor, and this is text editor as well. I'm gonna tell you a trick or whatever you call it, but when you get the list of all of the programs that has the SUID enabled, what you gonna do is we have the GTFOBin, as I have already discussed in the previous video in the kernel exploit that I was talking about this specific video. So we will go over here, and what we gonna do is, like, for example, we have this program. Okay, so you will come to this website, and what you're gonna do is click on the SUID, because we are talking about the SUID, and this will tell you the exact commands or every program that you can use to get some kind of access or do some malicious stuff. So I click on this SUID, and now these are the program name, actually the apt get. And let me move a bit more, and I'm gonna show you the find command that we talked about. This is the find command. Okay, and I, as you saw earlier, as you saw above, I clicked on the SUID. We can, if the find program has the SUID enabled, we can get the shell. And how to get the shell, we all we gonna do, I don't actually know, but this website will tell you. Now I click on the find program, and let me click on this, because we are talking about the SUID and we got a command. So if we run this command, and if the SUID is enabled on this find program, it will give us instant root shell. Okay, so that's how this work. Now coming back to this, let me move a bit and see what we're gonna study is same. We will move to this website, we will then see what program we get over here, and then we will look for the two main attacks we can do. Is when you find a SUID binary, there are two direction you can go depending on what the binary is. So the first thing we can do is we can use the program that has the SUID enabled, that can give us direct shell as root. Okay, some SUID binaries let you directly escape to a shell. This is the best, guys. Find it on GTFOBin, run the command, get a root shell, like the example with the find. And there are some other program even that might have the SUID enabled, but that won't give us the direct shell to us, but it can or it will be able to write or read to privileged file. Okay, like the shadow file or the pass file. More importantly, the shadow file, this is where the hashes of the password are stored. So if I go back, you can see there are some program that has feature like let me scroll, and you can see right here whatever program this is, whatever it does, but it can only read to file. Since let's assume this has the SUID enabled, what it gonna do is it will read to we can use this program to read some privilege or file that is owned by a root user. So that's how we gonna use them. And if you don't want to scroll and find out the program, what you gonna do is just type the, let's say we have the nano program, the nano text editor, and we will then click on the program, and then we will click over here on the SUID. So over here you see it will give us instant shell, a root shell. So if we type these command, I'm gonna show you exactly in a bit how we can do this. Okay, so coming back to this nano with the SUID. Okay, we have to complete different exploitation path for the nano. Nano is the text editor, as I said already. If nano has the SUID bit set and is owned by root, then when you can open nano, you can read and write any files on the system, because nano is running as root. So first of all, with the first method, what we're gonna do is what we're gonna do is, since nano run with the root, we will try to open this shadow file. This is where the hashes of the passwords are stored. So we will just type this specific command nano. This will open the shadow file and the nano text editor, and these are the hash file. And how these hash password can help us, like let me first of all go here and just run this command. Okay, so I went over here and try and did this to try to find out all of the program that has the SUID enabled. But in this notes, in this guide, and in this try hack me machine, they were actually telling me that we will be using the nano program. But this is the same exact machine you can see right here I'm using, and I actually don't see the nano program over here that has the SUID enabled. So I will just tell you the theory, and instead of the nano, I will try to find out another program that we can somehow use it to get the root shell. Right now I don't know myself what program I'm gonna choose, and I will let you know how we can find out what program we can use once we run this command. Okay, so let me just tell you in theory how this works. So we will use the nano, this run with the root permission. we will open this shadow file. Once we open the shadow file, this file contain the hashes of each of the user that on the Linux has. Like on the very first line we have the root user and the its hash password. So what we will do is, since we want to become root, we will copy the hash of the root, and then once we copy this, we will then move it to our attacker machine or somewhere else, and we will then use another tool. Like there are multiple tools, but the one I remember right now is John the Ripper, or we just simply call it John. We will use the John tool, and what we will do is, actually we will have a random files, like a file that has a random password, which is the roq.txt file, and we will be checking one by one password, and for one by one for each of the password in that file we will be creating the hash. Okay, so assume this is the password, this is one password, this is another, this is another. So for this password I'm gonna first of all make the hash password. Like this is the password in blank test, and this is the hash password, or this is the hash version of this, and for this is the hash. Okay, so for each hash I'm gonna match it or compare it with this hash. Okay, so let's assume I found a password that creates some hash password, and that hash password matches with this. So once it matches, we can then simply know that yep, this is the actual password. So this is how actually this first one works, and then these are the same thing that I just told you in very short. And if you want to understand, since we don't have the nano program right now, I would have done this practically, but if you want and if you are interested, I have done this as well in this video, so make sure to check it out. Now let's go a bit and see what are the other ways. Okay, so this is the another way we can use the nano program. This part B is all about creating a new root user. Like this is the file, as you already know, where the information about all of the user and links are stored, and another file is the shadow where the hash password are stored. So what this part B is all about is, this is the tool. Okay, and what it is trying to do is it is creating a hash password for a normal password. So this is the normal password. Okay, and we are using this tool to create a hash for this specific password. So we will get something like this output. Okay, once we get the hash password, we need to copy it somewhere, and we will then open this specific file with nano, since it runs with a root. So we will open this. Once we open it, the format for each of the user that is present in this is something like this. Like first of all the username, and then the hash password, and then the user id, group id, comment, home directory, and shell, what type of shell you want. So let's assume we want to create a new user with the name of hacker. Okay, and since we got the hash password over here, like we created a hash using the OpenSSL tool. Now normally what happens that instead of the hash passwords being stored over here, they just type the X over here, and then they put or store the hash password in the shadow file. Okay, so we will first put the hash password over here, and then set the user id to 0 like this right here you see, and the group to 0 as well. And then comment, this is just comment, it does not matter a lot, just we will type a root, and then home directory we will set it to root, and then the type of shell we want is bash shell. Okay, so what we will do next is we will then save this file by control X Y and then enter. And once the file is saved, we will then use the switch user command, su command, and to what user that we just created right now. So we will then type this, and then we will enter the password that we created the hash of. Like this is the password that we created the hash and stored the hash over here. We will then type the password over here. Okay, so if the hash password does not work over here, what you gonna do is, since the nano already work with the root, run as root, you will just open the shadow file as well, and then store the hash password over there, and boom, you will create a new root user. So that's how we can exploit the nano, that if it has the SUID enabled. And let's talk about the find. If find has the SUID, we can search the find there as well in the GTFOBin. Like type the find, click over here, and then go to this SUID. Since we are talking about the SUID in the previous video, I was talking about the pseudo, so I was clicking on this one. So right now we are talking about the SUID, that's why I am clicking. So if the SUID is enabled, we can simply come over here and copy this command, paste it over here, use it on the machine, and it will give us instant root access. Okay, so it is that simple. But right now neither I see the find command or and the nano as well. So these are all of the program that we got from here. Let me show you, these are all of the program. Okay, and I have told Cloud to tell me what are the program that can give me instant shell as a root when they have the SUID enable. Okay, and then this is the first block, this is the first category, these are the program that can give us the instant root shell. And these are the second category, they have the file read permission, like we can use this for the shadow and like to get the hash password of the root, the same thing that we did with the nano file editor. And this is another file write thing. Okay, another permission, but we will go with the instant one. Okay, before we continue, I just wanted to tell you something. As you saw, I was debugging and trying to find out a program that can give us instant root access. The issue with the program in the output that we got is none of the program give us the instant root shell. So what I'm gonna do is I will be going with the base64 tool that we spotted earlier in our SUID enabled binary list. Now if you want to skip the debugging portion and jump straight to where I start using the base64 from, just click the chapters or timestamp below and click on the one that says base64 and you will land there. But if you want to follow along with the debugging process like what I did and what went wrong and why, so just keep watching from here. Now let's get back to the video. We will go with the instant one, guys. If we get some program that can give us instant shell, why waste time on these? Even if you want to practice with these, just go with the go to the GTFOBin website. This is the website, and just type the program name. It will tell you exactly what you can do and how you can do. So I think I'm gonna go with this add program, AT program, and let me actually show you. This is the thing, this one exists on the list. This is the add program, and if I type the add over here, we got this, and let me click on this. And okay, I thought this command will work and give us the instant root shell, but I tried and it did not give me anything. This is the exact command I copied from Claude, and I thought I would go to the GTFOBin and then copy the command that GTFOBin is giving me for the add program. I also tried that, but it did not give me anything. Okay, I tried a lot. They first of all, I tried to check, none of these gave me instant root shell. Okay, I tried it on this GTFOBin and also with those two AI, Claude and Grok. None of these three are telling me that the program list you get that has the SUID enable will give you the insert root shell. And another thing is that I got, as we read, the created the hash password of the password of a user and store it in the TMP directory. But the problem is we got the line, but we need something, a program that can write to another file. And I also checked again all of these three, the GTFOBin, Claude and Grok, and all of three saying that there is no program that can write to other program. Though we have program that can just they can just read the file, but we don't need the read file, we need the write permission. So now here is the problem. Now I cannot do anything, none of these program do these, letting me write to program or giving me instant root. And the problem here is, the main big problem here is I cannot see the nano program, which is the very big issue over here. And this is the exact ROM as I told you earlier I am using, but they are showing that they have the nano program in the SUID. Right here you see this is the nano, and if we have the nano program, it is very easy to get the root. Like we got the hash password, we then created a fixed line, like we created for example this line, and this is the hash password that we got from the OpenSSL. Okay, we got this line, and since we have the nano tool, the SUID is enabled on the nano, what we will do is we'll use that and just we'll open this file. Okay, once this file is open, we can just simply copy this line from our another file and store it in this file, and we will then save it. And once it is saved, what we will do next is we will type the su or the and then the username, and once we press enter, it will ask for the password. Once we enter the password that we created the hash of the original password, it will then switch to the another. And since we fixed this, that will be a root user, so you see right here we switch to hacker user, and once we enter the password, you see right here this is the root user. And if we type the id, we will get that the user id is 0. Now I don't know if they did it on purpose or for is there is some bug or some error, but conclusion is that if we don't have any file, okay, that can write to other, the SUID is enabled on some program that can write to other. If we don't have that, that will be so hard. I think it will be impossible if only focusing on the SUID exploitation. Okay, so as I said, I will be using the base64. It's right here. I will be using the base64 from right here. But as you see right here, we have a list of 3 binaries of program. We tried that earlier, if you remember that, but it is a daemon, a background process, and it has we saw it has no shell. Okay, normally it does, the daemon has no shells. Now here we have 2 other binaries of program. So the base64 is something like the SUID is right now enabled on this, so we can, what we can do is literally it can read any single file, like even the shadow file or the password file or the terminal history. So let's get back to our terminal, our machine, and we will be using the base64 right here. And to let me show you what we will be finding. Since we don't have the nano or any other program, we will not get the root shell, but instead we can find out what is the content of the flag 3.txt. so we can use the base64 to read this file, and we will get that. And for the what is the password of user2, we will use the base64 to read the shadow file, and once we get the hash of this user2 password or of this user2 hash password, we will then crack it using the John the Ripper tool. Okay, so here you see we first like specify the file we want the base64 to read it, and like this l file equal to, let me type it, l file. So first of all, let me show you where the flag 3.txt file is. Let me type the ls and move to home directory, and again to ubuntu, and if I type here, the flag3.txt file is over here, but I cannot read it right now because we don't have the permission. So what I'm gonna do is to read the file using the base64, we will type the l file equal to the file location, which is right here, l file equal to this flag3.txt. okay, and what we're gonna do next is, since it run with the root access, I need to copy this line and paste it over here, and you can see we got the flag of whatever the content of the flag 3.txt. so I'm just gonna type it here, thm hyphen 384734. Yep, this is correct. And now we need to find the password for user2. okay, and in the last we will do this question, the another question. So right now what we will be doing is we will be copying the shadow file where the hashes are saved, and then also the password file. Let me go here. So we will get both of these file, and then we will use the unshadow tool. okay, so it will like kind of combine these 2 file and create a new file which we can use with the zone tool. So I just moved to the temp directory, and now I will type the cp command, which means copy, and then the shadow the password file is in the etc password, and I want to copy that file over here to my current directory with the name passw.txt. yep, and if I type the ls, we got the file, and we got this file right here, you can see. And now I need to copy the another file, the shadow file. So for that, similar thing, etc shadow and shadow.txt, or instead I use the base64 again to read that file, and whatever we get the output, we just put it in the tmp shadow.txt file which we got here. So now it's time to use the unshadow file like this. Where is that unshadow? Right now it says to move these two files to your attacker machine and then use the unshadow file over there, but I'm gonna use it here in this machine. Okay, we don't have the tool, so what I'm gonna do instead is okay, so the thing is I'm gonna start the python server on my Kali Linux. Okay, like this I was using this command, and once I start the command on the machine that we are doing these things, I will use this command. Let me show you the command, either this or this command. This will post the content, the pass.wo and the shadow file to my Kali Linux on the Kali, using the Kali IP, Kali Linux IP and its port. So first of all, what I want to do is let me move to the Kali Linux first of all. So I am on my Kali Linux now, and let me just move to downloads. Okay, I am in the download folders right here, and what I'm gonna do right now is let's start the Python server. So python 3 and -m http.server, and let me just use the port 8080. Perfect. Now I can just go to the another machine and actually use this command. I already, so this will post to this specific IP on this specific port. I need to change the port to 8080, and what file we want to post to this machine or this location, the pass.wo.txt, which is in the tmp directory. So let me just type the bash and cd tmp, so to confirm the pass and hash path, the another file exists, both of them exist. Perfect. Now I can just do this, and okay, so it is not working, I don't know. Let me go here, and basic python http server is read only, it cannot receive file via post. So okay, so that's the issue. We're gonna use one of these alternative. Okay, let's do this on our Kali machine. This will start the upload server, and then with this command the server will be started, and once the upload server is started, we then gonna use this to pause these two files to our upload server. And another way is, you can see right here, we can use the netcat tool. So we will open one terminal and we will start listening on for port 4444 for this specific file, and we will then open another terminal and listen on another port with another file, and on the target on the machine we will do this, and it will like kind of send those two files to Kali. So I think this one is a bit easy, since we need to download the upload server and do a lot more stuff. So I think this one is much better. So I stopped this http server and I am in the download folder. As you see, I started this netcat on this port, and let me copy this one as well. And first of all, let me move to the cd home/downloads. Okay, it's only download. Perfect. And now let me start this on this machine, and both are started, and now we can move to the another machine and just type these two commands. So I need to fix the IP over here. The Kali IP is this, and for the another file which is this, okay, this is the command, not that one. So this is the command and this is the IP. So I'm just gonna copy here that and paste it here. Perfect. And let me copy this, go here. I need to type bash so that I can get a bash shell, and cd to tmp directory, and let me do clear. And then okay, so the one file is I think transfer over there. Let's try this one now. Let me press enter. I think it is being moved there as well. Let's confirm both files moved there or no. Okay, perfect. You can see we have got both of these files, and now what we're gonna do is use the unshadow file to combine both of these. So this is the command unshadow, and I'm just gonna copy these and let me paste it over here. So it will make a new file with the name hashes.txt out of these two using the unshadow tool. Okay, so the issue we are getting is normally we have set the path for the commands, which is the usr user and slash bin, not the s bin. So the tool right here we are using is unshadow, is not in present in the normal usual directories or folders. So it is present in this or either this. So it is just telling us the path is something else, it is not present in the usual place. So what we did gonna do is I'm just gonna specify the path like this, and the same command as we type over here. So we will now give the full path of the tool and then the same stuff here. Okay, perfect. I think it created something, and let me type ls and we got the hashes.txt. If I type the get.txt, so we are, as I told you earlier, we will be finding the password for user2. So I'm just gonna type the get hashes.txt and the pipe and then grep the user2. So we are just interested in user2. Okay, so you see right here we made the file the hashes.txt, but when I tried to get the user2 hash, I was trying to see if there is something in it or no, but it was empty. So for the file transfer, previously I used the netcat this method, right? So it did for some reason I got the empty file, though I went to the another machine. The files were like, fine bro, it's raining hard outside. So the file were like fine, but I got the empty file. So I had another method over here. You see right here, this is it, and we just have to put over here the target IP where we are getting the files from. So I put the IP over here and then use this to get this file, and then I use this to get this file. Let me show you. I think I only did for the password file password.txt. So I type this command and it then asks me the password for the another machine, which is right here. You see I type this password one and I got this file again, and when I type the get, I got the file that has the content. Now I need to do the same for the shadow file because I think it has also a problem. So let me go here, and this is the same thing. All I need to do is to just, I think, change this to shadow.txt, and I think I am good. Let's do this and type the password. Perfect, we have also got the shadow.txt. Let's confirm by typing the shadow.txt grep pipe and grep user2. So we do see the user2 hash. Now we need to use the unshadow to make a hash to make a new file because the previous one was empty. So for that I'm just gonna use the same command again. This is the command and it will give me the another file, and let me type ls and do the get hashes.txt pipe grep user2. So we do see that there is the hash. Okay, and now we need to use a word list called rockview.txt. First of all, I need to verify if the rockview.txt exists or not. So I just copy the path. Usually it is present in this directory. So I'm just gonna type the ls-la, just l and the path. So we do see the rockview.txt is present, and I was just confirming. Now we need to use the tool John and then specify the word list. Okay, and then specify the hash or txt file which has the all of the user hashes, but we want to specify only the user2. We can also specify the root user or any other user, but they ask from us to find the password for user, so that's why I'm going with the user2. I will just copy this and go over here, and first of all let me do the clear. I cleared the screen, and okay, the same thing that we got with the unshadow. All we need to do is specify the full path of the tool. So I think it will be good now. So I think we got the password, which is the password one for the user 2. You see right here, session completed, and we got the correct password. So we got the password, which is the password one for the user 2. So this and this password are the same, so it means the password for Karen and the user 2 is basically the same. Perfect. You see how we use the join tool. Now let's move to the another machine and switch to that user 2. Okay, and let's answer the question as well. What is the password for user 2? Password dot one. And to show you the user 2 also exist in this, by typing the cat etc shadow, yep, not shadow, the password file, etc password. Yep, so this is the user 2, you see right here. Now I'm gonna use this su switch user to user 2, and password is pass. Yep, I think we logged in. Let's try the ID. So we are now user 2. Perfect. I am basically trying to find out this answer. I don't know where this answer would be. I just look over here in this walkthrough. They just said that you have to look in this file. I think we already looked, but I did not focus on the content of this a lot. So I type again the same command over here. You see, yep, this is the command I type, and we got the list again. And I just checked one by one to find out the author name, the comic book writer. So I found it over here, this Gary Conway or whatever that guy is. So the name here is Gary, GERRYCONVAY. Perfect. We have successfully answered all of these. And before summarizing what we did so far, I will just tell you some more technique that I recently found out. So this is the same command that help us to find out the SUID enabled binary, right? So you already know that. And this is, I think, some tool or something that I think help us to see what we can do with the program that has the SUID enabled. And one more important thing is in the third, you see right here, exploit writable location. Some SUID binaries may allow writing to files they execute if an attacker can modify a script or library used by the binary. It can be exploited to run as root. Like if I explain it in simple term, let's say if there is some program or some like any library or anything that has the SUID enable, whatever that file is, if we can modify that file, we will place our own malicious one, and when we try to run that file or binary, it has the SUID enable, so it will execute as root. See, the file write exploit by hijacking, we hijack the path. And then the library one that I have talked about this one in the previous video in the kernel exploit. So these are a bit new stuff that I have found recently. And so first of all, we understood what SUID and SGID actually are. The SUID, as I said, is a special permission that when it is enabled on a file, on an executable file that is owned by a root or any user, even when a normal user, when they run that file, it actually runs with the root permission or the owner permission. This is the whole concept of the SUID, right? And then we talked about the SGID, which work the same way, but instead for the user, it works for the group. And then we moved to the exploitation part. We talked about how we can find out all of the SUID enabled binaries or files on the system, on the Linux system, using the find command, right? And as you might remember, once we got all of the list, we then go to the GTFOBin website and check what we can do with those programs. If you remember earlier, I told you there are two different ways we can go with. The first one is if you have a program that can give you instant root shell, this is the best case, like the find program or the nano program, as I explained throughout the video. But in our case, we did not have those on this specific machine. So what we did is we went with the second direction, which is the reading privilege file, and for that we use the base64 binary, because as you saw, we have the base64 had the SUID enabled on the machine. So we use that to read the shadow file. The shadow file, as I told you, is where all of the hash passwords are. And since base64 had the root permission, so it was able to read the shadow file. And once we got the hash password of the user 2, we then used the John the Ripper to crack it. And after that, we found out the password for the user 2. So this is how actually SUID exploitation works. Sometimes you don't get the easy path, but you have to think and figure out what you have and what you can do with what you have. Okay, hope all of this makes sense. And in the next video, we will be covering about the Linux capabilities, which is basically a more control and special way Linux gives special power to program without giving it full root access, like kind of alternative for the SUID. So we will understand what capabilities actually are, and then we will look at how we can exploit them. So make sure don't miss that one. And I hope you guys understood everything. If you have any question, let me know in the comments. And if you found this video helpful, make sure to like and subscribe. See you in the next one.